Starting from two functions, how do we define a new function? Let's take the following example. We have the function f of x, which is by definition x plus 1, and the function g of x, which is by definition x minus 1. These two functions, when they interact with a given number x equals 2, well, you get the image of this number, which is f of 2, which is an abbreviation for 3, and g of 2, which is an abbreviation for 1. These two results, from these two results, you can sum them, multiply them, divide them, and subtract them. These are the familiar operations. So, for example, the summation of these two numbers. This is a familiar operation because it's just a summation of two numbers that you saw in elementary school. So, in this case, it gives 4. If you divide, for example, f of 2 divided by g of 2, well, you get 3. 3 divided by 1 is 3. And finally, if we multiply f of 2 times, or should I put a dot instead? A dot. G of 2, well, it gives again 3. The subtraction gives us 2, okay? So this is all familiar to everyone, but what we really want is not this. What we really want is to sum two functions, okay? If you start with two functions, you sum them, you get a new function. Or should I say, if you have two procedures and you sum the two procedures, you get a new one. For that new procedure, for example, we can label them. For example, if you sum two procedures, we label the new procedure by f plus g. If you multiply, we have something like this. And if you divide, for example, you have something like this. So from two separate procedures, you join them and you get something new. Okay? Now, what does this mean? Okay? You know what this new procedure means by describing how does it interact with a number, just like we did here. Okay? When you write f of x is equal x plus 1, you are essentially saying, well, how does f by itself interacts with 2x, okay? In particular, you have here how f interacts with 2, okay? But this is generic. Similarly, we must say how does this thing interact with a particular number. So let's do it. Let's describe how that new function acts on something, on a given number. So we have f of x, the label of the new procedure, or the label of the new function. Well, it acts on some domain, so the domain f plus g. It could be the real numbers, the entire real line, and it maps those numbers, well, into numbers, so it could be a real numbers, or specifically the range of the thing, f plus g. Now, for each element in the domain, let's call it x, is going to be mapped by this procedure, the new one, into the number f plus g of x. This thing here is a new number, okay? It is a symbol for a number that lives in the range of the function, okay? But what is this number? Well, you need to define it, so let's do it. This thing here is an abbreviation for the number that you get by summing f of x plus g of x. Okay? So again, the name of the variable, just like x is, just like x is the name of the variable that lives in the domain, this is the name of the variable that lives in the range. And that number in particular is an abbreviation for this thing here, which is also the symbol for a number that also lives in the range. This is just a more compact version of this thing. Okay? So this is for summation. Okay? Soon we'll see multiplication and division. They are analogous, but first let's convert this thing into a diagram. So in the diagram, let's specify first the first two key ingredients, which is our function f and our function g, which we describe just by a box. The box is the procedure. Well, from these two procedures, we join them by the summation operation, okay? And from these two, well, you have this thing here is the new function, you find here. And so when this new thing here, you feed, if you feed now a number x into this thing, you get the number f plus f of x plus g of x, okay? So, by looking at this diagram, what do we see? Well, we see here what this thing means, okay? This thing here, so it's like a factory. It has two departments, and they are joined. What this department does, well, is joined by what this department does through this operation, okay? And so, as all, we describe this as f plus g. And when f plus g, now the big box, the red one, acts on the number x, well, it gives us the number f of x plus g of x, by definition, okay? So we decided what this symbol is supposed to mean when it acts on x. Now, let's now describe, to be more specific, let's describe what this thing here, what this thing is supposed to mean. So f plus g, as it stands, is an abbreviation for the following recipe. Step number 1, you can see it on the diagram. Just evaluate f at the input. So, compute f at input, whatever the input is, okay? Whatever the number x you choose. So, step number 2, compute g at input, okay? Third step, sum the results from 1 and 2, okay? So this thing here is this recipe, whatever the input is, okay? Whatever the symbol that you choose for the input. Notice step number 1 and 2, corresponding to these two things. They are calculations as if f and g are completely independent. They never seen each other. But at step number 3, they interact. So the results here now interact at number 3. Just like here. First, they act on x independently, so these two directions, and then they collide, interacting, giving the new thing here. Okay? So this is the recipe that you act, and when this recipe acts, so let me write it, when the recipe f plus g now acts on some number x, okay, what do we get? Well, you just follow what you see here. So step number 1, evaluate f at x. You see? Input, now in turn you write x, the specific number that you chose. Step number 2, evaluate g at x. And step number 3, sum 1 and 2. Okay? See the difference? Here is a description of what you must do on some input. I don't know what it is yet. Okay? Here we are saying specifically when this thing acts on the number x, abbreviated by x that you chose, well, this thing here is an abbreviation for this thing here, and this thing here is a symbol. This thing is a symbol for a number, well, the number that you get after you do these 3 steps. Okay? So we are all the time in mathematics, we are always abbreviating stuff with new symbols and so on. Okay? Now, what can we say about the product and the division or subtraction? Well, it's very similar to this thing. So I'm not going to write it a new thing. I'm just, for example, let me just fix this thing. So if it's a product, well, instead of plus, we write something like this, a dot. And here we write instead of plus a dot, here a dot, here a dot. Instead of plus, you write a dot. It's a product of this thing, dot with this. Okay? That's the same thing for division. Okay? If it's division, you just modify the diagram, and you write here division. So this thing is the symbol for the ratio. Okay? The same thing for the difference, okay? Is analogous to the summation. So these are the main ideas, okay? The main ideas of how to define this thing. These are the four elementary operations that we saw. So summation, subtraction, product, and division. There is still one more to go, which is composition. We'll see that later, okay? But you can already see the idea is that you define the new. See, the idea is you define the new procedure through the elementary operations. How? By saying how the new function or the new procedure acts on numbers. Okay? So these are the main ideas. Now let's see some examples.